Hey everybody, we're going to start off this section. Well, there's going to be several sections to this because electrical gets a little bit um, complicated. I'm going to try to break it down to simple chunks. So you're going to see a series of different videos on this. I want to start off with just the basics, and why I'm bringing this up because when we get into air conditioning or any kind of service, really, electrical is a big thing and it's sometimes hard to understand. I really recommend that you take a electrical class, get into that and get the real deep end of that. When we're diagnosing, whether it be an engine performance or going into things like air conditioning, this all is very important. Really, any system on the car nowadays is some form, it's either electrical or electronic. So with that being said, let's go ahead and get started. I want to go ahead and open up this presentation. We're going to start off with this first part of it. And so let's go ahead here and I'm going to open that up and we'll get into the nitty gritty here. All right, let's go ahead and start from the beginning. So what we're going to do is start with an introduction, and we're going to get into a little bit about magnetism a little bit later on, and we'll talk about the different types of circuits. Now, the one thing I want you to start off understanding that there are basically three parts of it that we always look at, and we'll talk a little bit about Ohm's law too and how that relates to all this. So there's something you can't see, and this is where it really kind of causes us to think is, wait a minute, if I can't see it, I can't touch it. Well, you can kind of touch it, not advisable, but if I can't see it, then I can't understand it. Well, you're gonna have to do a little bit of an imagination here a little bit. But there are basically in electricity, there is actually it's pretty much what we consider electrons moving through that wire. So if you were able to look inside and watch these little guys run around inside there, that's the electrons that's actually buzzing around inside there. And that's what causes the light bulb to light, the compressor to come on, that solenoid to click on. This is what's happening. Now, there are pretty much three things that we look at, which, we'll get into that in a little bit here. You'll understand a little bit better. But we're talking about current, we're talking about voltage, and we're talking about resistance. So current, we a lot of times call what we consider amps, or amperage is the best way of looking at it. And it's pretty much those little guys buzzing around in there. These are the guys flowing across that wire, and this is what we call electron flow. So the other part that we have, which we'll get into a little bit here. We actually call electromotive force, which is that flow, EMF. Sometimes you'll hear things called EMF emissions and stuff like that. Basically, it's when anytime you put we're getting a little advanced here, but anytime you put voltage through wire or that amperage flow, we're actually creating a magnetic field. In the radio world, we use this a lot for transmitting information. And this is going through the wire, so you've got a little bit of actually an electronic force going through, which is causing the magnetic field to move like that. So this is one of the things that we want to make sure you understand. So we have other things that are causing pressure on this, causing that to actually flow through. So resistance, this is what opposes that. That's actually, you look at the wire, depending on the side of the wire, you have a resistance inside there. We don't have complete flow through, because we have to actually go through and move the electrons through that smaller wire, and that's why it's really critical when we're looking to replace the wire, or we're looking to modify something where we need to have more current flow to go through, and we may have to change the size of the wire too. And engineers, when they're designing cars, they look at what size wire needs to be in there, and they really don't go too much above that. They're given a little bit of an extra squeeze room, and what I mean by that is the size of the wire. If we have too small of a size of wire, it can actually overheat and melt the insulation, and we could possibly have fire. So in resistance, okay, so we talked about the size of the wire is important, and other things happen too. Even that electric motor, that solenoid, that bulb, all has a certain amount of resistance to it. So we measure the resistance, in a circuit as ohms of resistance. So we'll get down to a little more as we go across, but it's really important that we understand that the things that actually cause that resistance is the material that we use. Certain materials have more resistance than others, and actually the length, that wire, and also the temperature. Temperature can cause resistance to go up, and cooler temperatures can cause resistance to change also. So there's all kinds of things, factors that we look into when we're trying to diagnose a problem. That electric motor overheating, that can cause more resistance as we go across too. So voltage, the voltage, to summarize kind of what voltage is, it's the pressure. So if we were to look at in the amps, like we talked about earlier, so we need something to move that across and move those amps down that wire. And the way we do that is through voltage, and that voltage is what's considered pressure. That pressure to make that flow happen. So we actually use a symbol, there's different symbols as we go. The most common symbol that we use when we're working on things, we're looking at V as for voltage. You'll see some notation sometimes is E, the electromotive force, and amperage, of course, is going to be an A. More often than not, and then ohms is going to be that omega symbol to it. So the flow of the electrons need to that path to flow. That path is called a circuit, and one of the kind of the parts of the circuit that we need to have is some kind of battery, some kind of something that generates power, that where we store those electrons, and we have that pressure going on. So we basically talk about a battery that causes it, and then we need some kind of protection on that circuit. If we didn't have like a fuse or a circuit breaker or some kind of protection in a fusible link, we would possibly have an overheat, and then we'd burn that wire or that circuit. So we want to make sure we have something to protect it. The other thing we would have is some kind of control. Now, we can have different types of controls. It's, a lot of times it's a switch, but other controls could be like a relay. It could be a diode. It could be a transistor. It could be different things that actually have could cause that control circuit going on. When we get into smog and get into engine performance, there's other kinds of controls that we use. The computer could be considered a control also. And then, of course, I talked a little bit about the wiring that going to, and all this is what we have to have in a circuit. So let's start up with a basic circuit. Here's a typical circuit, and this is just what we call a series type circuit. And we'll get into the different types of circuits as we go along, but you can see that we have a switch. If we start off with the battery, generally that's what we like to start off with, and then we go through the wire. So this little line here is considered the wire, and that we have going together. Now we can have other forms of what we call conductors or wire. Sometimes we have a frame as the actual ground, so that you wouldn't have so much a wire, it'd be the frame itself. So there's certain things can be the conductors or the wire to it. But we have a battery here, we have the wire going across. Then we have a fuse. This fuse right here, this fuse actually is the protection. So we're just using a fuse. It could be a circuit breaker. There could be other things that are part of the protection, like like I said earlier, like a fusible link. Then we go up to our actual, which we've been talking about, our wiring. And then number 3 here is that switch. Now this is just a basic open, switch, normally open. And then we push that switch, it turns it on, or we trigger that switch over. That actually makes that happen. That could be a relay. It could be other things that cause that to come on. We use different things for different functions depending on what we need it for. And then of course what we're using the load. This is that resistance that I was talking about earlier. Now this, we're using a bulb here, right here, but this could be a blower motor, it could be a headlight, it could be other things that we are turning on. It could be that radio that you have in your car. All of it could go on. Now, one thing I wanted to point out too is that we have to go in completion. If we do not have, and I'll repeat this as we go along, if we do not have a completed circuit, the little electrons, and that pressure can't happen. If we unhook it or we do not turn on that switch, we're not going to have flow. We're not going to have that light bulb come on. All right, so good. So the next thing I want to talk about, kind of a little bit about, is about the different types of circuits. Now, this, I'm going to try not to get too deep into this, but I wanted to make sure you understand that they're not just one fits all. We have different circuits for different reasons. Now, there are 3 types of the most common, and we can have a combination of these two, especially in cars. And in cars, we have all kinds of things that we have to turn on, turn off. We have, like I said earlier, blower motors, headlights, tail lights. All this can be on different types of circuits. So the first one, which we really seen just a minute ago, was the series circuit. That series circuit is everything is connected together. And then we have what we call a parallel circuit. And I have some diagrams coming up in here in just a second. And then we have a series parallel where it gets a little more complicated. So let's go ahead and take a look at them. Now, these are the 3 common circuits. This is like we kind of talked about, but remember I said something about we could have a ground instead of an extra wire. Just think of that diagram before, that we had it all connected with a wire. Now we're actually using the frame to do this. So same kind of scenario, but we just go ahead and use the frame. So the frame, that way we can cut down on the wire in the car. This is why we use the frame a lot of times. So I have my battery up here, then I have my fuse or my protection device here, then I have my switch, and then I have, this is the symbol of a resistor, by the way, and this a little resistor here, or it could be a bulb, it could be a blower motor, whatever, and then we actually go to ground, so that ground can actually make a path back to the battery. And we just use that metal ground to do that. And then there's a parallel circuit. This is the second one. And battery, then we got the fuse, we still have the switch going on here. And instead of going straight across and connecting the resistors together, which we could do up here, we actually have a single path over to ground. And then we're going to have another path. Okay, so its own little path and it going to ground. We're still turning it on by this one switch. We could have two switches, turning one on, turning one off. We could do different things as we go across. So this is actually a parallel circuit. Okay, we'll get more into that as we start breaking the circuits down. And then we actually have a series parallel. So what we're going to do is take that same battery, that fuse, and then turn this on and off with a switch. And then we're going to actually go through one resistor that's actually in the series part. And then we go into a parallel circuit. So notice how it splits off. Okay, still have the resistance here, but we have this going through and we're going back down to ground. So we'll break that down as we go along. Now the series circuit, provides one path through it. Okay, all the way across. So we could put as many resistors, many of the light bulbs as we wanted, many whatever, and then that path has to go through all the loads before it comes back to ground. So if there's any kind of break in the circuit anywhere, the current can't flow, and then we have nothing coming on. So you kind of can see the importance of that. If we look at a light bulb circuit, and if we had those in the series circuit, that means if that one bulb went out, the other bulb will be affected. Now, if we have them in parallel, so one bulb goes out, the other one is not affected at all. The parallel circuit, this is where that light bulb scenario again, where we can actually have one path for each one. It doesn't affect the other one. There's two different pathways. That makes it easier for that to work. And if there's any kind of, you've probably seen this about on the road, you see one bulb really bright, one bulb a little bit duller. That could be, we have a bad, something in that circuit that has more resistance to it, like maybe a loose ground, maybe a connection problem. This could all be through that same thing. But notice we still have that one device that turns on both headlights. We have this in our parallel circuits. Now, the series parallel is a little more complicated, and you really get deeper into this in your electric classes. But an overview of that is we have kind of one path going through, and then it splits off. It's almost like a fork in the road. Okay, which way do we want to go? We're driving down here, and now, okay, we got a single path. Then we're going off whichever direction we want to go. That flow can go up through that first, resistor like it showed before, and then we can actually have it going through one side or going through the other side. Okay. So let's talk a little bit about Ohm's law. And Ohm's law kind of gives you the relationships between the three different, what we talked about earlier. We talked about amperage, we talked about the voltage, and we also talked about resistance. Now, when they're going through and they're designing the circuit, and this is important, that you understand that we need to know what size wire, we need to know what kind of effect that load, that bulb, that blower motor going to have on that wire. We also need to know what kind of voltage we're pushing through. So remember that voltage is pressure. So we have that battery. Okay, we got a nice size battery. We need to know what size wire, what kind of resistance that wire would be. And then we need to know what kind of resistance in that actual bulb. So we can design our circuit to make sure nothing, we still have a great, say a bulb glowing. We can also have to where that wire is not damaged. So we have the three, okay? So let's talk about the voltage. You know, like I said before, a lot of times they'll do it in V, or they'll use a symbol of E. If you get into more of the electronic circuitry designing, you might see it as an E. It's pretty much pressure. If you think of voltage as pressure, okay? So if we were to use the water tower analogy, we would have a water tower up, and we have a little valve to turn that water on, okay, to actually, water our crops. Maybe you're thinking about a shower, you get up there, you turn the shower on, and now the water flows through. So that's that little control valve, which we could consider a switch. Okay, so we're actually using the pressure or gravity or the pressure of the pipes to actually make that happen. So we have our voltage, and we're going to have that pressure going across. So that voltage is actually the pressure from gravity going down, or the pressure from the pipes. And then we have your current. A lot of times, the symbols we use in automotive is pretty much an A. It could be an I for intensity. Okay, so this is actually going back to the water tower again, or actually your pipe. How much pressure is in the pipes? How much gravity pressure is going from the water tower? So this is what we're looking at. Okay, so I should put it though. I'm sorry. We're kind of messed up there a little bit, but how much gallons flow? That's what I was really looking for. I kind of went back to voltage there for a second, but we're looking at how much gallons are going through that pipe, or how many gallons do we have in that water tower? So how much available do we have? So we're looking at a battery the same way. How much cold cranking amperage do I have? How much amperage is in that battery? Okay, so again, we're talking about amps. I apologize for kind of going back to where I was a minute ago there. Okay, and then resistance. This is the resistance to flow, the size of the pipe, the size of the wire, how much resistance is in that bulb, how much will that resist to go through, how much resistance is in that blower motor. Every component that does work for us has a certain amount of resistance to it. That's how it works, and we'll get more into that when we start breaking down our blower motors and our electric components as we go across too. So Ohm's law tells us that the current flow, okay, is directly proportional to the current voltage and inversely proportional to the circuit resistance. So we take all this in consideration. We look at what size wire, how that's the resistance, what size bulb we have, that's the resistance. We look at how much avoidable voltage we have, whether it be something like your cell phone, which is 3-5 volts inside of it, not 12 volts like our batteries are. Excuse me. And then we actually look at the amount of excuse me there, voltage available and how much pressure we have. Okay, so we look at the current, we look at the pressure, we look at also the resistance as we go across. So when voltage stays the same as the resistance and increases and current decreases, okay, so when we crank up that resistance, our current drops down. So it's almost like a teeter-totter. As resistance decreases, current actually increases. Okay, so it doesn't have as much resistance, so it can actually flow a little bit. The current can go a little bit more. When the resistance stays the same, if the voltage increases, current increases. And if the voltage decreases, current decreases. So we're all proportional. All right, so if two of the variables are known, we can actually calculate what the third one is. Now, I want you to take this a little bit with a grain of salt, because when you turn the circuit on, things change. but we can calculate, we can estimate, especially when it comes to calculating what size wire we need, what size battery we need, and what size bulb is going to go in there. So we can calculate that by using Ohm's law. This is you'll see this more and more, especially when you get your electrical classes and also in energy performance classes. In my smog classes, we talk about this because you need to know this. So this is an easy way of doing it. So we look at our little diagram here, a little picture here. If we know, okay, so E equals, so to figure out what E is, we can actually multiply the actual amperage times the resistance, and we'll get the actual voltage out of it. So remember, we can actually have a V, or you might see an E. Don't it gets a little confusing, but you'll get it. You'll get it. So if we want to figure out what the the intensity or the amperage is, we have to take and divide the battery voltage or the voltage by the resistance. So we just take that voltage and we divide it by the resistance. If we want to figure out the resistance, then we actually take the voltage and divide it by the actual amperage. All right, so let's try this out. All right, so if I have a, I know what the battery voltage is, okay? So I know it's a 12 volt, and I know that my actual, I know what my voltage is, I know what my resistance is, then what do I have to do? If I look at my, kind of go over here and we'll cover up, the actual, the amperage, so my I. So I know I have to divide my my resistance into my voltage. So if I take that and I divide 4 into 12, I actually come up with my my amperage of 3. Okay, see how easy that is? Now this is actually for a parallel circuit. So we need to be careful of that because, series circuit, we need to be careful when we go into parallel, I'll walk you through that also, but it comes a little bit different. So if I know what my my resistance is 6 ohms, okay, of resistance, and I know that my amperage is 2 amps, what is my voltage? Okay, so remember, we have to go a different route now. We take my actual my resistance times my amperage, and I come up with, yeah, you got it, 12 volts. Okay, see how easy that is? So now if we go back again, and I want to check out my resistance, I have to take and divide 6 into 12. Okay, you're kind of getting into that, and I can find out my resistance of 2. So it becomes pretty simple after you've done it a few times, and this is your simple, circuits like that. So you kind of get the idea, and I hope this has been beneficial. I'm going to go ahead and get us into the next section. I wanted to go for a basic, because when this kind of splits off to where we go into the electrical class, it goes deeper into this, kind of rabbit hole here, or we go back and take it from here for our basic classes and some of the electrical classes, because when I get into some of the electrical classes, I go a little bit deeper, and some of them I stop here. And then there's also when I get into air conditioning and this type of class, and obviously transmissions too, because everything is electronic or some kind of electrical involved in it. So hopefully it was beneficial. If you have any comments, please feel free to comment and send me an email, send me a text, and I'll be more than happy to answer your questions. Right, take care, and we'll get started again soon. I'm going to go ahead and stop this. All right, folks, till the next video.